and we're going to go on to our last talk of the day from our very own Hurtado. So go ahead and take it away.
Thanks, Ferris. Hello, everybody. I'd like to share some closing thoughts with you on how the science operations team for Artemis can be enabled to carry out collaborative exploration with the crew, amongst each other, and with a larger community. Next slide, please. So my take-home message, so given advancements in imaging, virtual and augmented reality, telepresence, there's an opportunity to virtually bring the lunar surface to the Artemis science operations team and vice versa. So we should provide the science operations team with the tools to increase their agency to be proactive, collaborative participants in the exploration, rather than being limited to reactive directors or passive observers of the exploration. Next slide. So in this concept, the exploration site and the crew activities there will be imaged at high resolution using footage obtained by the crew as well as other platforms. These data can be used to generate 3D visualizations of the exploration site. This stream of data, including imagery and derived data products, as well as the capacity for the science operations team to more directly communicate with the crew, will allow for the science operations team to both have enhanced situational awareness as well as promote more collaborative science with the surface crew. Next slide. So among the things needed to enable this concept are these 4 technologies and protocols that I list on this slide. So imaging assets, and I'll talk a little bit more about those later. Mobile robotic assets, perhaps, of the kind that Kirby just talked about. A virtual explorer role in the science operations team. That's someone to manage and interact with this data stream. And then finally, as I mentioned, communications pathways and protocols to allow more direct communication, perhaps not always, but at least when it's appropriate, between the science operations team and the EVA crew. Next slide. And you can skip this slide, thanks. So the Artemis EVA data stream will be image-centric in real time. So compared to Apollo, this is going to be a fundamental shift, I think. Whereas Apollo had low-resolution TV camera footage for EVAs, they had no ability to see the astronaut photography in real time, and there was a heavy emphasis on the audio for good reason. For Artemis, we're going to have the potential to be awash with real-time, high-resolution video streams along with audio. So critically for this concept, the visual data can be photogrammetrically processed to produce, and as the fieldwork progresses, continually refine 3D models of the exploration site and the astronauts' activities. In principle, the 3D data set I'm talking about could be solely obtained using just the cameras that are nearly certainly going to be part of the EVAs already. So things like suit-mounted cameras or rover-mounted cameras. And importantly, those cameras could be passively acquiring video the entire time without much interaction from the crew at all. Now, as Kirby just talked about, another end member would be a dedicated mobile asset, like a robotic platform that could be commanded from Earth. Next slide. And I'm going to skip this one too. Thanks. Let's see. I think you skipped ahead quite a bit there.
Yeah, sorry. It's doing
okay.
it on its own.
No worries.
And it won't go. Oh, here we go. Tell me when to stop.
I think one more after that one. Thanks. Okay, so data processing. So this scheme, this little pie in the sky, will require the communication to Earth from the moon of large volumes of image data in hopefully near real time to enable the kind of 3D data stream that I'm talking about. So 3D video sort of immediately to the science operations team, and then higher level data products available in the minutes to hours time frame after that. These can include things like point clouds, 3D models of rocks or outcrops, digital elevation models. As has been mentioned earlier today, the bandwidth limitations will be a significant constraint on doing something like this. Next slide. So while that's coming up, just a little bit more on data processing. There's going to be challenges imposed by this scheme on things like storage and transmission of large volumes of data, processing hardware and software to automate image processing, for instance, and then synchronization of data streams geographically and also in a time-coded, horizontally integrated manner. And we had some great talks earlier that talked about the software tools that form the basis of this that are already in development. Next slide. This scheme is also going to require data visualization and manipulation of these data sets. So tools are needed for using this imagery for doing science support operations. So for visualization, there are things like 3D workstations or maybe even large visualization rooms, certainly things like 3D headsets, which would be needed by the science operations team. Software is also going to be needed to enable the tactical usage of this data, to basically allow the science operations team to have some degree of telepresence and situational awareness. And the JPL AMOS system that was presented earlier today is a great example of the kind of software that could do that. Similarly, software to enable offline strategic usage of the data is needed, again, for collaboration among various facets of the overall team. That includes the crew and also the science operations team, or even outside collaborators and the public at large. Next slide. So I've mentioned this virtual explorer a couple times. So what is it? In my mind, essentially, this is the member of the science operations team that manages and interacts most closely with this integrated 3D visual data stream. To one, maintain situational awareness with crew activities and their surroundings, and also to provide sort of eyes in the field capacity to make collaborative science contributions to what's going on. So like Kirby just talked about, basically almost like an avatar there in the field. One member of the role of a virtual explorer would be to use this large volume of 3D situational awareness data in a tactical manner similar to in Apollo, wherein the observations and recommendations would be relayed to others on the science team as well as the crew via Capcom, but only as necessary. Next slide. A somewhat higher level of interaction would be what I call over-the-shoulder guidance. So here the virtual explorer could almost literally be looking over the crew's shoulders and have some measure of direct communication with them, say text if not voice, to for example, talk through and collaborate on science procedures and science tasks, and basically talk the science. I envision something like the invaluable interaction you might have with a field partner doing geology fieldwork. An important note here is that this interaction, while arguably valuable, may not be practical while the EVA is going on. But post-EVA collaborative discussion of the EVA science centered around the 3D visual data sets obtained during the EVA could be enabled in this concept. Next slide. And then I won't spend much time here because Kirby gave a great talk on this, but at the highest level, we could have a virtual explorer role that could basically be accomplishing science independently of the EVA crew if the mission is equipped with the appropriate robotic assistant. Next slide. Now, as I close, I see two other compelling use cases for this sort of virtual explorer concept in the science operations team. One with access to a large sort of 3D data set of the lunar surface. One is in training. So staffed by an astronaut, the virtual explorer seat becomes a valuable potential source of real mission experience in gaining visual experience of what the lunar surface is like, or what science operations are like, and real immersive interaction with the science and mission operations team. So imagine an astronaut in training for the next mission could be seated there in the science operations team interacting with this data. Next slide. And then finally, this capability lends itself to education and public outreach. What better way to engage the public and the next generation than by giving them a front seat view of traversing and exploring the moon? In addition, and I think we've all learned this in the past year, online virtualized experiences can lend themselves to more diversity, inclusion, and accessibility, since participants need not be physically present to meaningfully contribute. And because this can be highly scalable, we could potentially allow a larger number of people, including the public, to engage with lunar surface science. Next slide. So just to summarize some of the benefits I see in a concept like this, this can facilitate knowledge and situational awareness transfer among all members of the exploration team. This includes both the crew and the science operations team to maximize their science productivity and ensure mission success. The virtual explorer role in the science operations team will enable vicarious, virtual, remote, all these adjectives, exploration ways that I don't think were possible with Apollo. And then finally, this concept is scalable so that a large number of individuals could collaboratively be involved, not all of whom are co-located, and potentially increasing pathways for participation in Artemis science. Thank you.
All right, great set of talks and perfectly on time. Thank you so much.